Okay, let's find antiderivatives of trig functions. Okay, and there's a formula for this too, and I'll show it to you in a minute. But let's first explore the guesstimation technique because it might pay off too. Okay, so we want to ask ourselves, all right, whose derivative is sine of 2x? Okay, because I'm looking for the function whose derivative is sine x. So let's find. So here's what I would ask myself. Well, if I take the derivative of cosine of 2x, what do I get? I get negative 2 sine of 2x, which is close, except for this negative 2. Okay, so if I can make that go away somehow, I would have, hey, sine of sine 2x, right? And all that needs to happen for that to happen is I need a negative 2 in the denominator. Okay, so if I want my final product to have a negative 2 in the denominator, it's basically a negative 1/2, I can actually throw that into my original derivative here, and it won't go away when I differentiate. Okay, here I'll show it to you just in case you don't believe me. I'll just do 1/2 negative 1/2 times cosine of 2x. Okay, so if I take the derivative of that, what do I get? I get negative 1/2 multiplied by negative 2 sine 2x, right? And the 2's will cancel, and a negative times a negative is a positive. Okay, so I started out, I have a good idea, a good shot in the dark is that, hey, well, if I take the derivative of sine, or if I take the derivative of cosine, I'll get sine, so I'll start there, and then I'll just modify my little derivative here, and until it works. I take the derivative, and it gives me back what I put in. So then I can go ahead, and I can say that, hey, antiderivative of this function right here, that is negative 1/2 cosine 2x, of course, plus c. Or you could just do it this way. That's supposed to be a k. Okay, so you have a trig function. There's always going to be some sort of constant in front of the angle, okay, whether it's a 1 or whatever, so you can just go there, right? Okay, let's do another one. Let's find the antiderivative of cosine to the 1/3 of x. Okay, so I'm asking myself, whose derivative is cosine 1/3 of x? Okay, so I know that I'm going to involve some cosine action. Okay, so let me just take sine. Let's just take the derivative of that. So what is that? That is equal to derivative of sine is cosine. We use the chain rule. Okay, so the only difference here is I need a 3 up top, right? Okay, so if I write a 3 up there, I can actually write the 3 out here, right? I mean, really, if the derivative of a constant is 0, but if it's a constant along with a variable, then it just goes along for the ride. Okay, so I could just go dx of 3 sine 1/3 x, and that would equal what? That would equal 3 okay, that'll cancel out, and then I'm back to what I started, right? Okay, so it looks like I can go ahead and say that the antiderivative of cosine 1/3 of x is 3 sine 1/3 of x. And this also holds true. Our little generic formula here. Of course, put my plus c there, because see what's the reciprocal of 1/3? It's 3, right? So, hey, it strikes again. Okay. So let's see here. Where else do I want to go with this? I'd like to get some more paper, but do I have any paper? Do I have any paper? Crap, I'm out of paper. Oh, I'm out of paper. Let me get some more paper. Hang on. How about this one? Here's a good one. This one will be probably one of your best friends in Calc 2. Okay, so what happens here? So this is equal to x to the -1 dx, right? So I want something that, you know, if I take the derivative of it, I will get x to the -1, right? But if I go ahead and if I use my power rule, I'm going to end up with a -1 plus 1 in the denominator. The boat does not float if we do that, okay? So I guess there's really no other simple way to do this, but and if you don't already know it, okay, the antiderivative of x to the -1 is a natural logarithm of the absolute value of x. And that makes sense too, because remember back when you took the log, or the derivative of the log, you would end up with that exact same thing. Okay, so your guesstimation tactic doesn't quite work there, okay, but it works somewhat. Okay, so that's a good one. And ooh, how about this one? How about the integral of e to the 2x? Well, see, let's see here. I know that e to the x, you know, its derivative is, you know, always the same. But let's see here. So what if I took the derivative of e to the 2x? What would I get? I get 2 e to the 2x, right? Okay, using the chain rule and everything. But I need that 2 in the denominator, so I can go ahead and throw that in there. Okay, so it turns out that that one has a pretty handy formula too. Okay, and those are pretty much the most basic forms of them. Okay, and the other one after this, these are the ones you're going to have to memorize. Okay, so where are we going here? Just let's do a recap. Okay, you're gonna have to write this down on a piece of paper and keep it next to you. Okay, you're gonna have to keep this one handy. You're gonna have to keep this one handy. Okay, and you're also gonna have to keep this one handy. Okay, then when we start getting into integration, you're basically gonna have these probably memorized, and then we'll use those along with the power rule to figure out all the other ones. Okay, so I'll see you in the next bunch of videos.